Hi students, today topic 3 and 4 Euclid's division lemma and algorithm. Actually topic 3 is fundamental theorem of arithmetic, but change the topic 3 and 4. After Euclid's division lemma and algorithm, I will tell you fundamental theorem of arithmetic. First I will tell you Euclid's division lemma. What is lemma? First you should understand what is lemma and what is algorithm. See, lemma is a proven statement used for proving other statement. What is algorithm? An algorithm is a series of well-defined steps which gives a procedure for solving a type of problem. You see, algorithms, software engineers, they will write algorithm to do any program. They will call algorithm as pseudocode. Before going to understand Euclid's division lemma and algorithms, you should understand some basic concepts. You see, I am dividing 6 with 2. What is it? 6 is dividend. This is divisor. I am dividing 6 with 2. 2 3s are 6. What is the remainder you got? 0. 0 is the remainder. This is divisor. This is dividend. This is quotient. This is remainder. You should know all these things. How you will get 6? If you multiply divisor with quotient and adding remainder, you will get this dividend. See how you will get dividend? 6 is equal to divisor into quotient plus remainder. What is the remainder here? 0 is the remainder. You see, 2 3 is 6 plus 0. You will get 6. What is 6? What is 6? This is called dividend. Is equal to, what is 2? Divisor. What is 3? Quotient. What is 0? Remainder. Now you should understand dividend is equal to divisor into quotient plus remainder. Now I am dividing 16 with 3. 3 5s are 15. What is the remainder you got? 1 is the remainder. What is the dividend here? 16 is the dividend. What is divisor? 3 is the divisor. What is 5? 5 is the quotient. What is the remainder? 1 is the remainder. You see, dividend is equal to, means 16, how you will get 16 dividend is equal to divisor. What is the divisor here? 3 into, what is quotient here? 5 plus remainder. You see, what is the remainder here? 1. 3 5 is 15 plus 1, 16. You are getting dividend. That's why you should understand, before going to Euclid's division lemma, you should understand dividend is equal to divisor into quotient plus remainder. This quotient and this remainder are unique. Unique means in the world every person is unique. Unique means different. These two are, this is quotient Q. It is denoted by A. Dividend is denoted by A. And this is divisor is denoted by B. Remainder is denoted by R. What is dividend here? A is equal to divisor. What is the divisor here? B. B is the divisor. What is the quotient? Q. Plus what is the remainder? R. See, A is equal to, dividend is equal to divisor into quotient plus remainder. See, you should understand this one. I am dividing A, that is dividend, with a divisor B. You are getting a quotient and the remainder R. Quotient Q and remainder R. This Q and R are they are Q and R are unique. Unique means they are different. You should understand that one. Then we can go to Euclid's division lemma. You should understand dividend is equal to divisor into quotient plus remainder. Here remainder, when I divided 6 with 2, I got remainder as 0. Then we can say 6, 2 is the factor of 6. 3 is the factor of 6. You should know this one also. 6 can be written as 2 into 3. 2 is the factor of 6. 3 is the factor of 6 because you got the remainder as 0. Here you are not getting remainder as 0. Therefore, 3 is not the factor of 16. 5 is not the factor of 16. That's why you see you are not getting remainder as 0. 3 is not the factor of 16. 3 is 5. 5 is also not the factor of 16. But here you are getting remainder as 0. That's why 2 is the factor of 6 and 3 is also factor of 6. So this is very important. Dividend is equal to quotient. Dividend is equal to divisor into quotient plus remainder. This remainder may be equal to 0 or greater than 0, but it should be less than b. You should understand this one. Then you can go to Euclid's division lemma. What is Euclid's division lemma? Just next I will tell you. Now Euclid's division lemma. Lemma means it is a proven statement used for proving another statement. What is Euclid's division lemma? Given positive integers a and b, there exists unique integers q and r satisfying the relation a is equal to bq plus r is greater than or equal to 0 and less than b. Already you know dividend is equal to divisor into quotient plus remainder. Already you know. How can you prove this? Dividend is equal to divisor into quotient plus remainder. You see, you take 6, you divide 6 with 2, 2 3s are 6. What is the remainder you are getting? 0 is the remainder. This is divisor. This is dividend. This is quotient. This is remainder. See, means how you are getting dividend 6. 6 you are getting divisor into quotient means 2 into 3. 2 into 3 plus what is the remainder here? 0. 6 is equal to 2 into 3. 2 into 3, 6. 6 is equal to 6 because remainder is 0. Here, what is the remainder? You are getting remainder as 0. Remainder is greater than or equal to 0 but less than equal to b. B means, see, this is a, this is b, and this is q, and this is r. See, I will give you another example. 7. I am dividing 7 with 3. 3 2s are 6. What is the remainder you are getting? Remainder you are getting is 1. See, dividend is equal to 7. How you are getting? Divisor into quotient plus remainder. What is the divisor here? 3 into quotient is 2 and remainder is 1. How you are getting? 3 2s are 6. 6 plus 1, 7. 7 is equal to 7. You observe the remainders here. This is the remainder r and also this is the remainder r. Here remainder is 0 and here remainder is 1. Remainder is greater than or equal to 0. Here it is 0. Here it is greater than 0. Means 1 means it is greater than 0. But less than b. B means what is b here? See, b is divisor. Remainder is greater than or equal to 0. But less than b. B means divisor. What is divisor here? 3 is the divisor. Here also you see. Remainder, it is 0. It is less than the divisor 2. The 0 is less than 2. And also you should understand this one. A is equal to BQ plus R. Now again you read, given positive integers A and B, there exists unique integers Q and R satisfying the relation A is equal to BQ plus R is greater than or equal to 0 and less than B, means divisor. If you want to understand, you see, I am taking dividend. A company distributes dividend, its dividend means profit to shareholders. They will get some amount in rupees or shares. Like that, this is dividend. Here dividend is A. And we are dividing it with B. Divisor is B. What is the quotient you are getting? Q is the quotient. And you are getting the remainder as R. You observe, A is dividend is equal to divisor into quotient plus remainder. What is dividend here? A is the remainder. A is the dividend. What is the divisor here? B. And what is the quotient here? Quotient is Q plus what is the remainder? R. But he is saying that if you divide a dividend, any number, a positive integer with another positive integer, you are getting the remainder is greater than or equal to 0 and less than its divisor. You see, you are getting a quotient. This quotient and remainder are unique. Unique means different. Every person in the world is unique face, means different face, like that. Say unique means different or distinct. You see, A is equal to BQ plus R. This R is greater than or equal to 0 but less than or equal to divisor. You see, observe these two examples. In this example, we are dividing 6 with 2. You are getting remainder as 0. As A is equal to BQ plus R. As in this case, dividend 6 is equal to divisor into quotient plus remainder. In this case, divisor. What is the divisor here? 2 is the divisor. As in this case, remainder is greater than 0. You are getting 1. It is greater than 0 but less than the divisor. What is it? It is less than the divisor, means 3 is the divisor. Here remainder is equal to 0 and less than the divisor. Like that, A is equal to BQ plus R means you are getting remainder is greater than or equal to 0 and less than the divisor. Euclid division lemma is also called division algorithm. Hi students, now Euclid's division algorithm. Euclid division lemma is already over. What is lemma? It is a proven statement to prove other statement. You see, lemma Euclid's division lemma is over. Now Euclid's division algorithm. First, before going to Euclid's division algorithm, we should know about Euclid. Euclid was Alexandrian of Egypt. He wrote 13 books on the elements. Before 2300 years back, you wrote the elements. Now, what is Euclid's division algorithm? Using Euclid's division algorithm, we can find out the HCF, means highest common factor of A and B. A should be greater than B. We know when we divide 6 with 2, 2 3s are 6. We are getting remainder as 0. What are the steps to find out HCF, highest common factor of two positive integers? See, we are dividing 6 with 2, 2 3s are 6. We are getting remainder as 0. You see, apply the division to find Q and R where A is equal to BQ plus R. R is greater than or equal to 0 and less than B. Already I told you, when you divide 6 with 2, 2 3s are 6, 0 is the remainder. Here we are getting remainder is 0. Remainder is greater than 0 means if you divide 8 with 3, 3 2s are 6. You are getting remainder as 2. What is the quotient? Q is the quotient. What is the remainder? R is the remainder. What is this dividend? Dividend is A. What is 3? This is B. You see, when you divide a number with another number, you are getting remainder as 0 or greater than 0 but less than divisor. You see, you observe. Remainder is here is 0. This 0 remainder is equal to 0 or greater than 0 means you are getting remainder as 2. It is greater than 0 and also you observe that remainder is less than the divisor. You see, you observe remainder is R is less than the divisor. You see, this is B, this is A and this is Q. You observe in every case, in each case remainder is equal to 0 or greater than 0 and it should be less than B. B means divisor. You see, B is divisor. Here you see, B is the divisor. This is remainder is greater equal to 0 or greater than 0 but less than divisor. Here R is equal to 0 and remainder is less than divisor means this is B, divisor. Here also R is greater than 0. You are getting 2. Greater than 0 means 1, 2, 3. These are all numbers are greater than 0. Positive numbers. R is greater than 0. In this case, you are getting 2. R is greater than 0. And also R is less than divisor. R is less than divisor. What is it? 3. Next, if R is equal to 0, the HCF is B. If R is equal to 0, what is HCF? HCF is B. Here HCF is B. HCF is B means that is equal to 2. What is HCF? Because we are dividing 6 with 2, it is completely divisible. You are getting remainder as 0. 2 is the factor of 6. 3 is also factor of 6. That's why what is the HCF? You are getting remainder as 0. That's why the HCF of 6 and 2 is 2. Next, what is HCF in this case? You see, if R is not equal to 0, here R is not equal to 0. That's why what we have to do? If R is not equal to 0, apply Euclid division lemma to B and R. What I have to do? You have to divide again. See, again I will do here. What I have to do? Again we have to divide with 2. We have to divide 3 with 2. 2 ones are 2. What is the array? Remainder is 1. Again you are not getting remainder as 0. Again you have to apply Euclid's division lemma to find B and R. Means 1 and 2. 1 2s are 2. You are getting remainder as 0. That's why what is HCF? You are getting remainder as 0. That's why HCF is HCF of 8 and 3. 8 and 3 is 1. That's why 3 and 8 are co-primes. You know, already you know. What is the HCF of co-primes? HCF of co-primes is 1. That's why 3 and 8 are co-primes. See, that's why continue the process till the remainder is 0. We have continued the process till the remainder is 0. First what I have to do? First you have to apply division to find Q and R. That is A is equal to BQ plus R. I have divided 6 with 2. You are getting remainder as 0. If R is equal to 0, the HCF is B. R is equal to 0, you got HCF is 2. In this case, HCF of 6 and 2 is 2. Next, in this case, you are not getting remainder as 0. Then what you have to do? If R is not equal to 0, applied Euclid division lemma to B and R. Again, what you have to do? We have to apply Euclid's division lemma to B and R. Means B and R means divisor and remainder. I have divided 3 with 2. You are getting remainder as 1. You are not getting remainder as 0. Again, what you have to do? You have to apply Euclid division lemma to 2 and 1. You have to divide 2 with 1. 1 2s are 2. You are getting remainder as 0. Now, what is the HCF? You have to take HCF of 3 and 8 is 1. That's why they are called coprimes. We will do this example. Use Euclid division algorithm to find HCF of 108 and 12, 108 and 72. This example I have given. We will do this example. Now, use Euclid's division algorithm to find HCF of 108 and 12. What is another problem? 108 and 72. What do we have to do? Apply division to find out Q and R, where A is equal to BQ plus R. We have to divide. We have to divide 108 with 12. Let us check whether we are getting remainder as 0 or not. 12 9s are 108. We are getting remainder as 0. What do we have to do? We have to write A is equal to BQ plus R. What is A here? A is 108 and B is 12. We have to write A is equal to BQ plus R. A is equal to BQ plus R. What is A here? 108 is equal to. What is B? This is B. 12 into. What is Q? This is quotient. 9. 9 plus what is R? 0. Yes, 12 9s are 108. What is the HCF of 12 and 108? As remainder is 0, we have to take HCF of these two numbers is 12. What is the HCF? HCF is 12. Because you are getting remainder as 0. If R is equal to 0, the HCF is B, means divisor. If R is not equal to 0, in this case you see, we will take this case. This problem we will take, we have to divide 72, we have to divide 108 with 72. What happens? See, 108, one time it will go. What is the remainder? 6, and you are getting 36. What is the remainder? 36 is the remainder. Always remember, always this remainder is less than the divisor. See, you are not getting remainder as 0. What do you have to do? Again, you have to, R is not equal to 0. Apply Euclid division lemma to B and R. What is B and R here? This is B and this is R. We have to apply Euclid's division lemma to 36 and 72. Again, what I have to do? 72. 36 2s are 72. As you got remainder as 0. Like that. What is the HCF here? 36 is the HCF. HCF. This is HCF. You see, you have to write in the form of A is equal to BQ plus R. What is A here? A is equal to BQ plus R. What is A here? 108 is A. What is BQ? B is 72. And what is Q? 1 plus what is the remainder here? 36. Continue the process till the remainder is 0. We are not getting remainder as 0. We have to continue the process till the remainder is 0. We have to continue this process till the remainder is 0. Again, I have divided 72 with 36. You got the remainder as 0. Now, again, what you have to do? You have to take 72. How can you write 72? It can be written as 36 into 2. 36 into 2, you are getting 72 plus what is the remainder? As remainder is 0. That's why we have to take HCF is, we have to take HCF, we have to take B, we have to take 36 is the HCF. I think you have understood Euclid division algorithm.